So this week we're going to look at simplifying and rationalizing radicals, or roots. So this first one talks just about simplifying radicals. So what you're going to do with your root is first do a factor tree. Factor trees are your friends. They're the easiest way to work through these because they're not things you can just type in your calculator. Your index will tell you what size of groups you need. Now, when you're looking at a root, you've got a number under it, and then sometimes you have a little number outside. That little number is called the index. If there's not one, that's a square root, which means it's 2. Otherwise, it could be a 3, a 4, a 5, whatever. When you're looking at that, if n is odd, so if n is 3 or 5 or 7, then a is allowed to be a negative number. It might be positive, it might be negative. If this is a even number, 2, 4, 6, so on, this cannot be negative. So you're only going to work with ones that do work. So if this is odd, this could be negative, and if that's the case, you're going to get a negative answer. Otherwise, you're not going to have to deal with too many negatives here. Okay, so we know what our group size is. We've done our factor trees. We find those groups. Things that are in groups come out of the root. Things that don't have a group have to stay in. So it's like if you don't have a partner, you got to do it all on your own. Only the partners get to come out, or the groups of 3 or groups of 4. Okay, so let's try a couple problems and see how we do. So first, we're going to do the fourth root of 648. Now, I know that's a big number, so you've got options for your factor tree. It's even. We could just start dividing by 2s. You could try 3s, 4s, 5s. Just start going through the list if you can't see something that goes in nicely right off the bat. I've done this, and I tried 8 just because it ended in 8. I thought, okay, maybe it works with 8. It does. So if we break it up, we'll get 8 and 81. Those are a little bit more manageable numbers. 81 we know is 9 and 9, and 8 is 2 and 4. So our 9s both break up into 3s. That 2 is good, and this 4 breaks up into 2 more 2s. So there's our factor tree. Now we're going to look at the index. Remember, the index is right up here. It's 4. That means we need groups of 4. So if I look at these bottom numbers, the ends of our branches, I have 4 3s. So I'm going to circle that because that's a group. Okay? My 2s, I only have 3. So I don't have enough to make a group. So this guy gets to come out. These guys are stuck staying inside. So if we go and write our answer, the 3 comes out. Now it's a group. They all stay together. It's not 4 3s. It's just a group of 3. And then I still have my fourth root of everything that's left over. Now these are left over. They're not complete groups, so they're like individuals. So we actually have to go back and put them back together, multiply them together. 2 times 2 times 2 is 8. So our answer is 3 times the fourth root of 8. That is as simplified as it gets. And if you typed them in a calculator, which I know it's fourth root, so that's hard, but if you did, you get the same weird decimal because they're the same thing. It's kind of like simplifying fractions. Okay, we talked about what happens if the index is odd and we have a negative number inside there. That means we're going to have a negative answer. So there's that negative. We just have to remember in our final answer, it's going to be a negative as well. So we do our factor tree for this guy, 216. I'm going to say 6. I tried that. It does actually work. It's 6 and 36. 36 breaks down into 6 and 6. Now at this point, you kind of have options. You could keep going because these would all break down into 2s and 3s. Or if we look at our index, we need 3 of a kind. I have 3 6s. So if you see that you've got the same number however many times you need it, you can stop there, or you can keep breaking it down. I'm going to stop. There's my pair, my group. There's nothing left over. So that means there's going to be no root in my final answer. Remember, we said it's got to be a negative, so we have negative 6. So sometimes you still have roots in your answer. Sometimes you don't. It just depends on the individual problem. Okay, let's try another one. Square root of 512. Now, there's no number there. Remember, that's the square root. That means we need 2 of them. So once we're done with our tree, we'll be looking for pairs. I did this, and 8 and 64 worked. 8 we know is 2 and 4. 64 is 8 and 8. So this one I broke down all the way into the smallest pieces possible. And I ended up getting a whole bunch of 2s. I'll underline them so we can see them all. Now remember, this was an index of 2. We need 2 of a kind. So here's a pair, here's a pair, here's a pair, here's a pair. But that guy's left all by itself. So when we go to write our answer, I have 1, 2, 3, 4 2s that I'm bringing out. So 2 times 2 times 2 times 2. And then I have the square root of this extra 2. So my final answer, well, 2 times 2 times 2 times 2 is 16. So my final answer is 16 square root of 2. So factor tree, index tells you what size your groups are going to be. And from there, you bring out those groups and leave in the things that don't fit in a group. That's simplifying with just numbers, but we also can simplify if we have variables. So when we have variables, the key thing to pay attention to is the exponent, because the exponent tells us how many of that thing that we have. So let's do a few of these. So the square root of 54x to the third. So we're going to work with the 54 just like we did the last few problems. That is 6 and 9. So a 2, a 3, a 3, a 3. And then x to the third means I have 1, 2, 3 x's. So these are all my little pieces down here that I've got. It's an index of 2, that invisible 2, so I need 2 of a kind. So this guy's by himself. There's a pair of 3s. There's an extra 3. Here's a pair of x's and an extra x. So just like before, things that we circled in our pairs come out. So 3 and x. And then we are left with a 2 times 3, which is 6, and another x. So we had 3 x's, I need a group of 2. It's like if there's 3 students and I tell you to find a partner, somebody has no partner. There's that extra one left over. We can do this with higher powers. Let's try a fourth root. 648 r to the third. So 648, let's do our factor tree for that. 81 and 8, 9 and 9, a whole bunch of 3s, then 8 is 2 and 4, and a couple more 2s. Now we have r to the third, so that also means I have, we'll put them over here, 1, 2, 3 r's. So I need 4 of a kind. So 1, 2, 3, I got 4 3s. 1, 2, 3. I only have 3 2s, so they can't come out. I only have 3 r's, so they can't come out either. So the only thing that's coming out is this 3, and then I still have the fourth root of 2 times 2 times 2, that's 8, and r times r times r is r to the third. It's like if there's 3 students and I say make a group of 4. You can't. You need another person, so you're stuck not being in that group of 4. Okay, let's try a -1, just for practice. Negative 56x to the 6th. So we know our answer is going to be negative. Don't forget that when we get to the end. 56 breaks down into 7 and 8, 2 and 4, 2 and 2. And I have 6 x's. So 1, 2, 3, 4, 5, 6. I'm writing them out just so you can kind of see and it's easier to circle stuff. We need that 3 of a kind. 7's all by himself. I do have 3 2s, so I'll circle those. Here's 3 x's. Here's another 3 x's. So we're going to have 2 x's that come out. So we have the 2, we have an x, we have an x, and then we still have that cube root of 7. Well, x times x is x squared, so our final answer would be 2x squared times the cube root of 7. So sometimes your variables will completely come out, just like sometimes your numbers will completely come out. So that's simplifying with numbers with variables. Go ahead, do the first part of the worksheet or the first part of the Quizalize or the simplifying quizzes, and then you can watch the second video about rationalizing.